This is the first of a series of lectures of embedded systems. So in this first video, we're going to go over the basics of electric circuits. A really simple circuit basically consists of a battery, resistor, and we'll use a diode, a light emitting diode. We'll use 6 volts for the battery and 1K for the resistor. And the diode is rated at about 2 volts. You can check the datasheet for the specific voltage levels. So basically, this is the positive side and this is the negative side of the battery. The negative side is usually the ground, denoted by this symbol. So the problem in this case, we want to measure what is the current flowing through this circuit. So we're going to use Ohm's law, which is one of the important laws in electrical engineering. So Ohm's law states that voltage across a node is equal to the current through the node times the resistance of that node. So we're going to take this node here, and first, so we want to know what the voltage is across this resistor. V sub R is equal to, so we know that this is 6 volts, this is 2 volts, and so 6 minus 2 is 4. So that's equal to 4 equals, and then the current is the unknown, and also note that the current through the whole circuit is the same according to another law, and the resistance is of course 1000 ohms. So the current would be 4 divided by 1000, which is 0.004 amperes, which is the SI unit of current. So that's the same thing as 4 milliamps. So now we're going to test this in the lab. Okay, so this is the lab part of this video. Here we have simple circuit. Here we have a resistor, an LED, and basically connected from power here from the top to the ground on the bottom. So we have a DC power supply here powering 6 volts, and we have a multimeter here. We're going to measure the voltage and current. So first, let's measure the voltage across the diode. So the voltage across the diode after we turn it on is about 1.72 volts. Let's measure also the voltage across the resistor, which is 4.3. Okay, now let us measure the current through this circuit. do that, we have to wire it up in series. Okay, so now we can measure at milliamps, and we measure 4.33 milliamps. Okay, so basically our circuit is the same here, except that the voltage here we measured was 4.3, and across the diode was 1.72, and that should add up to 6 volts here, that is supplied by this battery. So the voltage is basically divided up between these two components here, and the current we measured was about 4.33 milliamps, and this actually, we can actually derive this current using Ohm's law, V equals IR. So basically we already know what the voltage here, if this is 1.72, so basically 4.3 volts equals to I times resistance 1000 ohms. Let's use SI units. So then current would be 4.3 divided by 1000, so that gives you 0.0043 amps, or 4.3 milliamps. So that's pretty close, about plus or minus 30 microamps from the measured current here from the multimeter. I would say that's a pretty accurate answer. Thanks for watching.